In today's video, I would like to introduce a very nice problem regarding arithmetical number theory. Here is the following setup. Find this triplet ABC as a natural number, satisfy this following equation. So we get a nice symmetry here. We get a cubed plus b cubed plus c cubed equals 2001. Okay. We are simply just reducing the equation to them as something in order to determine these values more easily. Okay. Now let's jump into the solution. Now to find out which appropriate module we can use here, so we are going to check 2001. So notice here 2001 equals 9 is multiplied by 222 plus number 3. Okay, this one is going to give us an idea how to reduce this equation. So we are simply going to reduce this equation to the mod 9. Okay, so get here, this one is a congruent to 3 mod 9. On the other hand, we are going to work on the left hand side of this equation. So notice also here we get a cubed is always a congruent to minus 1 0 1 mod 9. Okay, so I'm not going through the chart. You guys, you can go through the chart and check, and then it shows all the possible values of a. You will see the remainder is minus 1 0 1 mod 9. Okay, so we are simply going to use this fact. Since we get the remainder 3 here, which means the left hand side of this equation must be also is a 3 mod 9. Okay, the only way to get 3 mod 9 on the left hand side of this equation, which means each of the term must be congruent to 1 mod 9. Okay, so this one is telling us a cubed is a congruent to 1 mod 9. So by symmetry, so we get also b cubed is a congruent to 1 mod 9, as well as c cubed. Now when you try to sum them, you get remainder 3. Okay, so this one is going to give us a cubed plus b cubed plus c cubed is a congruent to 3 mod 9. Okay, which is satisfy the right side of this equation. So now since we get here, get e cubed is a congruent to 1 mod 9, this one implies a is a congruent to 1 mod 3 by taking the third root on both sides. So this one is simply going to give us this one. Okay, now since we determined a is a congruent to 1 mod 3, also this argument follows similarly for b and c. Also I get b is a congruent to 1 mod 3 as well as c, because of the symmetry. Okay, so we get these 3 important statements. So we are going to go through this one. I'm going to check the largest value of c or b or a, either one. Okay, so let's do that in order. So without loss of generality, assume a is inferior to b, b is inferior to c. Okay, so the most important thing here, we are going to determine the largest value of c, since c is bigger than other integers. Okay, if you take a look up here, if you replace number 13 here, it satisfied this statement because 13 is a congruent to 1 mod 3. But we are going to check on the other side as well. So if you replace 13 here, is not going to satisfy this equation because 13 cubed is going to be bigger than this one. Let's try on this one, because 13, if c equals 13, which means c cubed, which equals 13 cubed, which is strictly superior than 2001. Okay, so adding to other values here is going to give us strictly a big inequality, which is not going to satisfy this equation. Okay, so which means this one is telling us c must be strictly inferior than 13. Okay, to make it more easier, we are going to use this statement. Okay, which is those values smaller than 13 satisfy this one. It's more simple. C belongs to this set 1, 4, 7 and 10 only. since we have proven C is strictly inferior than 30. Okay, Because replacing here 10 is a congruent to 1 mod 3, which is true. Replacing 7, you get 7 is a congruent to 1 mod 3, which is true. 4 is true. Number 1 is true. Okay. So this is the only values C can take. Okay. So now also we know 3c cubed equals c cubed plus c cubed plus c cubed, which is super equal to a square e cubed plus b cubed plus c cubed, which equals 2001. Okay. So dividing both sides by 3 is going to give us c cubed is super equal to 667. Okay. Because dividing 2001 over 3 is going to give us 667. Okay. So taking the cube the root on both sides, this one immediately C is taking number 10. Okay. Because replacing 10 here, you get 1000 is bigger than this one. Because replacing 7, because the value which is smaller than 10, which is 7, which is satisfied this statement. 7 is not going to satisfy this inequality, because 7 cubed is giving us 343, which is not satisfied this one. Okay, which means the largest value of C equals 10, which is verifying this inequality. So let's replace the value of C into this setup to find A and B. So this one is going to give us E cubed plus B cubed, which equals 2001, by taking this C cubed to the other side, which is 1000. 1000 is going to give us 1001. Okay, like this. So this 1001 equals 9 is multiplied by 111 plus the remainder 2. Okay. So if you reduce this one to mod 9 as I did before, this one is a congruent to 2 mod 9. Okay. So it's giving us the same thing as we previously discussed, so which means B is a congruent also to 1 mod 3. So the same job that I have done before, so we'll get the same thing here. So also I know 2 times B cubed, which equals B cubed plus B cubed, which is super equal to A cubed plus B cubed, which equals, so more simple here, I get B cubed is super equal to over 2. Okay, this one is going to give us 500.5. So this one taking the cube the root here, so this one is the largest value of B here is going to give us 10. Okay, because 10 here, I get 1000 is bigger than this one. If you take in the value 7 as I have here, you get 7 cubed 343, which is not bigger than this one. So which means B always B equals 10. Okay. Replacing 10 here, get 1000, which means 1001 minus 1000 is giving us number 1. This one immediately is going to give us A equals 1. So now I will have 3 solutions. Okay. So I get A equals 1, B equals 10, with C equals 10. Okay. By symmetry, I will have 3 copies of this one. So I get here, I get A equals 10, with B equals 1, with C equals 10. Lastly, I get A equals 10, B equals 10, finally C equals 1. Okay, this is the only 3 solutions that I find. Thank you for watching. I will see you next video. Bye.